A flicker breaks the darkness. Are we witnessing proof that we are not alone?
For centuries, humanity has looked to the skies, searching for a sign, a signal, anything that might prove we are not the universe's sole inhabitants. Every generation has wondered if, somewhere out there, another mind stares back. Now, in the early years of the 21st century, a new chapter unfolds, a chapter that could change everything, and it starts with a single, mysterious light on a distant world. If that is true, everything shifts. The idea that humanity stands alone in the universe would be shattered, replaced by a new reality. We are just one among many. Such a revelation would overturn our understanding of biology, technology, and our place in the cosmos. It would echo through every field of science, every culture, every faith, demanding new answers to the oldest questions.
This light defies the ordinary. It repeats at regular intervals, forming patterns, shapes, and structures that nature seldom creates by chance. The regularity is unsettling and precise, unlike the chaos of weather or the randomness of geology. Some researchers, after months of careful study, dare to voice what once seemed unthinkable. The signal could be artificial, a deliberate construction, perhaps even a message.
The James Webb Space Telescope, the most advanced observatory ever built by human hands, has revealed something astonishing. On Proxima B, a remote planet orbiting the closest star beyond our sun, more than 4 light-years away, a strange light pulses. Not a random flare, nor a cosmic glitch, but a pattern, a repeating signal that cuts through the static of the cosmos. For decades, scientists dismissed Proxima B as a dead, radiation-blasted wasteland battered by stellar storms. Now, Webb's latest images tell a new story, one no one expected.
What makes Proxima B such a riddle, and why has it captivated scientists as both a promise and a warning? The answer lies in the history of its discovery, its brutal environment, and the hopes and fears projected onto its distant surface. We stand at the edge of a mystery that could redefine existence itself. How did a forgotten, seemingly lifeless planet become the focus of the greatest astronomical discovery of our age? To understand the significance of what Webb has found, we must start with what we thought we knew about Proxima B. Its history and our evolving perceptions hold clues to why this light is so shocking and so important. At first, hope soared. Proxima B orbits within the so-called habitable zone, the narrow region around a star where temperatures could, in theory, allow liquid water to exist. For decades, this has been the gold standard for searching for life, and Proxima B seemed to fit the bill. But excitement quickly soured as harsh facts emerged. Just over 4 light-years away, Proxima B was uncovered in the year 2016, not by a sweeping telescope image, but by a faint, rhythmic tremor in Proxima Centauri's light. This subtle shift, detected by astronomers at the European Southern Observatory, betrayed the gravitational pull of an unseen companion, a planet with a mass about 1.17 times that of Earth, locked in a relentless orbit around its parent star. The discovery was a testament to human ingenuity, using the tiniest ripples in starlight to uncover entire new worlds. Then, everything changed. The world's most advanced telescope was about to turn its gaze toward Proxima B, and what it would find would shatter every assumption and ignite a firestorm of debate. Proxima Centauri, a red dwarf star, is no gentle neighbor. Unlike our own sun, it lashes out with brutal stellar flares, flooding its planets with ultraviolet and X-ray storms. These tempests are up to 100 times more violent than anything our solar system endures. Over time, such cosmic fury can strip planets bare, erasing atmospheres, sterilizing surfaces, and leaving only silence. Some studies suggest that Proxima B, so close to its star that it completes an orbit in just 11.2 Earth days,
would be bombarded so frequently that the very idea of habitability seemed doomed. So for nearly 10 years, astronomers clashed over Proxima B's destiny. Was it doomed to be a scorched, irradiated husk, a planetary grave? Or could something endure beneath its battered surface? Some imagined protective magnetic fields like Earth's, or thick atmospheres like Venus's, sheltering life against the onslaught. Others insisted that nothing could survive in such relentless hostility, citing examples from our own solar system, Mercury's airless waste, or Mars's thin, radiation-lashed sky as warnings. Yet the argument runs deeper than this single planet. If we decide that life cannot take root in these brutal environments, we may be blinding ourselves to entire realms of biology, alien forms that might thrive in places we call impossible. Consider Earth's own extremophiles, bacteria that flourish in boiling acid springs, fungi that survive deep within Antarctic ice, and tiny tardigrades that can endure the vacuum of space. These creatures remind us that life is not only adaptable, but often tenacious, finding ways to persist against all odds. Perhaps, some argued, we should not be so quick to declare Proxima B barren. A pattern of lights on a dead planet. Nature or something more? With the unmatched vision of the James Webb Space Telescope, humanity reached farther than ever before. Webb's near-infrared camera, NIRCam, and mid-infrared instrument, MIRI, both tuned to capture the faintest whispers of heat and light, sent back not just images, but data. Direct thermal maps of a distant, shadowed world. These maps carried spectral clues, the clear fingerprints of carbon dioxide, water vapor, and a perplexing methane spike. Together, these signatures suggested chemistry that could, just maybe, belong to life. On Earth, a similar combination is often found in environments where living organisms are abundant. For example, methane on our planet is largely produced by microbes and animals. Its presence on Mars, though in tiny amounts, has sparked decades of speculation about the possibility of subsurface life. Now, on Proxima B, the stakes are far higher. A new signal would soon emerge from Proxima B, one that defied explanation. Humanity would have to confront the possibility that we were not alone. But before diving into the details of this extraordinary discovery, it is worth recalling how, in the past, seemingly impossible signals have challenged our understanding, sometimes leading to paradigm shifts, sometimes to disappointment. In 1967, for example, Jocelyn Bell Burnell detected a repeating radio signal from deep space. For a brief moment, some thought it might be a message from extraterrestrial intelligence, and it was jokingly dubbed LGM-1 for Little Green Men. It turned out to be a pulsar, a rotating neutron star. History is filled with such moments, when the boundary between hope and science blurs. Yet nothing was as unsettling as what emerged from Proxima B's eternal night side. There, where the planet hides from its violent red star, Webb found not random glows, but structured patterns of infrared light. These were not flickering storms or wandering lava flows. Instead, the lights formed lines, clusters, and repeating shapes, geometric, deliberate, and eerily precise. The world's scientific communities froze, transfixed. No natural phenomenon known to us produces such flawless symmetry. Not the auroras dancing over Earth's poles, not the lightning storms that rage across Jupiter, not even the intricate crystal lattices of minerals or snow. 3 fiercely competing theories erupted within days. The first, powerful atmospheric currents transporting heat from the dayside, creating glowing patches on the night. But the patterns Webb saw were too precise. No weather system forms such perfect grids. On Earth, even the most regular jet streams or ocean currents meander and shift. The second, volcanoes, their lava fields blazing in the dark. Yet volcanic eruptions are wild and chaotic, their light scattering and fading, never aligning itself in strict formations. Everything was at stake. If we mistake alien technology for the randomness of nature, we risk missing the first greeting from another intelligent world. But if we see meaning where there is none, we endanger the very credibility of science. Around the globe, debate erupted, skepticism clashing with hope.
Was this the evidence we have dreamed of, or an illusion born of our longing? That left a third, far more disquieting possibility, an artificial source. The symmetry and consistency of these lights echoed the order of technology, not geology. Could this be the deliberate work of a civilization shaping energy at a planetary scale? Was this a message or the footprint of industry? On Earth, nighttime satellite images show cities glowing in patterns, grids of streets, clusters of industry that echo what Webb has seen on Proxima B. Could we be seeing, for the first time, the cosmic equivalent of city lights? A deluge of data poured in as teams raced to verify the signal. Each new analysis brought both answers and deeper questions. If this is what civilization looks like beyond Earth, how should humanity respond? And what comes next? The implications are vast and unprecedented. The world held its breath. Was this the moment humanity found company in the cosmos? To avoid errors of the past, international teams began a rigorous process of peer review, using independent instruments to verify the signal. They cross-referenced data with ground-based observatories, checked for artifacts in the Webb's detectors, and reran the analysis with different software. This meticulous approach echoes the caution taken in 2015, when a strange signal from the star KIC 8462852, later called Tabby star, prompted speculation about alien megastructures, only to be explained by clouds of dust. The world staggers beneath the weight of revelation. Spectral analysis from the James Webb Space Telescope uncovers something uncanny on Proxima B. Organized light patterns reflected in ways only structured surfaces, perhaps metals, could produce. These are not random flares, but signals, calculated and precise, echoing the hallmarks of design. On Earth, our own cities, highways, and even agricultural fields reflect light in distinctive, patterned ways when viewed from space. Could Proxima B be home to an alien civilization that has harnessed energy on a planetary scale, perhaps even exceeding our own technological achievements? What kind of life could shape such wonders? Proxima B is a planet gripped by extremes. One side scorched by endless, relentless day, the other locked in frozen, silent night. Only a slender band, the twilight zone, offers the faintest hope of habitability and eternal dusk where the two worlds meet. If life endures there, it must be the ultimate survivor, an extremophile able to withstand lethal radiation, wild temperature swings, and scarcity, recalling Earth's most stubborn forms of life. On our own planet, extremophiles thrive in places once thought uninhabitable. The Deinococcus radiodurans bacterium, for example, can survive doses of radiation thousands of times higher than would kill a human. Tardigrades, the so-called water bears, can endure the vacuum of space and temperatures from near absolute zero to over 150 degrees Celsius. In the deep ocean, entire ecosystems flourish around hydrothermal vents, where sunlight never reaches and conditions are toxic. If Earth's life can be so adaptable, perhaps Proxima B's could be even more so. This discovery detonates across the globe. Within mere hours, the scientific world pivots. Every radio array that SETI commands turns toward Proxima Centauri, straining to catch even the faintest whisper. Project Starshot, once a remote ambition, now surges forward, rushing to send interstellar probes no bigger than grains of rice, not to chase dreams, but to seek answers. The Breakthrough Listen initiative, which has scanned the skies for artificial radio signals for over a decade, reprioritizes every available instrument to focus on Proxima B. Meanwhile, plans for the construction of massive new radio telescopes, like the Square Kilometre Array in Australia and South Africa, are accelerated. Every next-generation eye humanity has built, the extremely large telescope in Chile, the Roman Space Telescope in orbit, and more, now sharpens its gaze on Proxima B. International teams form overnight, pooling resources and intellect to decode this cosmic riddle. Collaboration eclipses rivalry, at least for now. The United Nations convenes an emergency session, calling for guidelines on how to proceed. Should we send a reply? Should we wait? What risks and opportunities lie ahead?
But with hope comes hazard. Misreading these signals could spark crushing letdowns, wasted efforts, or even social upheaval. In the 1970s, the so-called WOW signal, a 36-second burst of radio from deep space, sparked similar excitement, but was never repeated. Yet to ignore this beacon, to look away out of fear or doubt, would be to forfeit a leap in both science and spirit, a loss that might haunt generations yet unborn. Public imagination erupts. Art, music, and film race to envision new worlds and possible neighbors. Philosophers and theologians scramble to interpret what this means for humanity's soul. Political leaders argue over policy, budgets, and urgency, while skeptics warn against delusion and disappointment. The debate spills into every sphere of society. Some draw parallels to the discovery of America by Europeans in the 15th century, a meeting of worlds that changed everything, though not always for the better. Others recall the Copernican revolution, when humanity was forced to accept that Earth is not the center of the universe. The psychological shock of finding intelligent life would dwarf any previous paradigm shift. Our search for meaning sharpens, and the world holds its breath. Whatever comes next, humanity stands on the threshold of a new era. In the past, discoveries such as the detection of exoplanets or even the first images of black holes have opened new scientific frontiers. But never before has the possibility of intelligent life felt so immediate, so present, and so urgent. Still, the greatest challenge is not technical, nor merely political. It is existential. We are forced to confront the timeless question, what if we are not alone in the universe? The discovery of another sentient civilization would demand a rethinking of our philosophies, our religions, our sense of purpose. Would it unite us in a common cause, or divide us in fear? Would it inspire new technologies, or lead to caution and retreat?
What if we are not alone? And what if, at this very moment, something else is watching us too? The discovery is not simply a string of data or a curious anomaly. It is a mirror held up to our deepest longings, our oldest fears, and our boldest dreams. For thousands of years, humanity has stared at the stars, asking if something or someone might be out there. Now, this strange, deliberate light from Proxima B demands that we confront what happens if the answer is yes.
If there truly is life on Proxima B, then we are not the universe's only storytellers. Our belief in being unique, the single bright spark in an endless dark, would be forever altered. Suddenly, we are not the center of the narrative, but one voice among many. Not a lone island, but part of an unimaginable archipelago. This would be a transformation as profound as when Galileo first turned his telescope to Jupiter and saw its moons, proving that not everything revolves around us. The search for life is more than a question for scientists. It is a thread that connects generations, cultures, and distant hearts. Every civilization has looked up, yearning for a sign, hoping for connection. This search has always driven us to invent, to risk, to reach for what seems impossible. Whether or not we find intelligent neighbors, the journey itself expands our sense of what is possible. The Voyager Golden Record, launched in 1977, carried greetings in dozens of human languages and music from across our planet, an interstellar message in a bottle. Now, perhaps, we are receiving a message in return. In the end, the question matters as much as any answer. If we turn away from this moment, we risk being trapped, shut in by the comfort of old certainties, ruled by fear of the unknown. But if we face the mystery, we unlock new eras of discovery, new technologies, and new meanings. Even a whisper of life on Proxima B could ignite revolutions, ways to communicate, travel, or even perceive ourselves that we can scarcely imagine. Already, researchers are exploring new methods for interstellar communication, drawing from mathematics, art, and even music, searching for a universal language.
Above all, when we gaze at Proxima B, we are really seeing our own reflection scattered across the cosmos. Whether the light comes from another mind or not, this search transforms us. The night sky, once empty, becomes alive with possibility and wonder. It reminds us that we are explorers, and that the greatest chapters of our story have yet to be written. The Apollo missions, the Mars rovers, and the Hubble Deep Field all taught us that to look outward is to grow inward, to become more than what we were. Now, with the world holding its breath, the question is no longer whether we should look outwards, but whether we are ready for what we might find. The next decision could shape the fate of humanity itself. Should we attempt to send a deliberate message, risking the unknown, or simply listen and learn? What protocols, if any, should guide our actions? The SETI post-detection protocols, debated for decades, are now more relevant than ever, but even they may be inadequate for the stakes we face. The possibility is electric and terrifying. Accepting it would shatter our comfortable solitude, forcing us to redraw the map of our place in the cosmos. It hints at knowledge and inventions beyond our wildest dreams and calls forth a new empathy, a reminder that we might not be the only minds searching for meaning in the void. The prospect of contact, however distant, demands humility, curiosity, and care. Perhaps we are not just gazing at a distant world from afar, but finding ourselves under its gaze as well. For thousands of years, we have scoured the heavens, certain that we alone are the watchers, never the watched. Yet this pattern of organized light on Proxima B challenges everything. What if it is not a fluke, not an artifact of data or geology, but a deliberate beacon? What if, across the light years, another intelligence is signaling, waiting patiently for us to notice? To answer this summons is to embrace wonder and risk. We could learn what it truly means to be alive among the stars, to share our questions, hopes, and fears with another civilization, to realize that life is not confined to Earth, but may be woven into the fabric of the universe itself. This moment could unite humanity in curiosity, driving us into a new era of exploration and purpose. Imagine a future where we learn from another world's mistakes and triumphs, and where we find common ground in the shared challenge of existence. Yet, turning away has consequences. If we let skepticism or fear close our eyes to these signals, we risk locking ourselves in a cage of ignorance, isolated by our unwillingness to listen. We could forfeit the greatest conversation in human history, a dialogue that might upend everything we believe about existence. The cost of silence may be far greater than the risk of reaching out. The question debt, built over generations of searching and dreaming, is finally coming due. Humanity stands at the threshold, ready or not to meet the answer. With the eyes of the world, and perhaps others, upon us, our next steps will echo across the cosmos for ages to come. So, what path will we choose? Will we answer the light, or retreat into silence? The universe has reached out. Our reply, thoughtful and deliberate, will not only shape our science, but our destiny. History has shown that every time we open a new window on the universe, we are changed by what we see. This time, that window may show us a reflection, not just of another world, but of ourselves.